Hello students, in this video we learn how to write the rate expression. So before that we should know about the rate of the reaction formula. That is change in concentration by time taken. We can also denote this by del C and del T. So one thing you have to keep in the mind is when the reactant gets converted to product, the reactant disappears while the product appears. That is, when the reactant gets converted to the product, the concentration of the reactant R decreases while the concentration of the product increases. So from this, we can write the rate expression. The rate of reaction for the reactant R is, that is the change in concentration, will be dr and the time taken will be dt. Here we will put negative sign because the concentration of the reactant decreases. Now we will write the rate for the product. It will be d of p by dt. This will have a positive sign because the concentration of the product increases. This is the simple concept that will help us to write the rate expression. Now let's proceed to write the rate expression for this reaction. 2a plus 3b gives 4c. Here the number 2, 3, 4. These are known as stoichiometric coefficient. The numbers which are present in front of the reactant or the product, these are known as stoichiometric coefficient. So now let's see how we can write this. So whenever you write the rate expression, you should equate all the concentration of the reactant and the product. Okay, now let's see how we can write the rate expression for this reaction. Now to make it simple, let me write the rate expression only for the reactant side and separately for the product side. Now let's write for the rate expression for the reactant. That is, we have A here and B as a reagent here. So what will be the rate expression then? dA by dt. It will have a negative sign. Remember, because the reactant will always decrease in the concentration while the product will increase. dA by dt. We have to equate the reaction again. Negative d of B by dt. Okay, got it? Okay. Now we have to go for the stoichiometric coefficient. The stoichiometric coefficient will be divided below this rate law expression. That is, we have 2 here and we have 3 here. Always remember the stoichiometric coefficient goes below the rate law. Okay. Now we have written the rate of reaction for the reactant. So if we further simplify it, this is 2 by 1 while this is 3 by 1. When we take the reciprocal, we will be getting minus 1 by 2 dA by dt is equal to minus dB by dt. Sorry, that is minus 1 by 3 dB by dt. So this will be the rate expression for the reactant only. Now let's write the rate expression for the product. Now we will write the rate expression for the product. That will be d of C by dt. Here the sign will be positive as the concentration of the product will be increasing. And always keep in mind the stoichiometric ratio will be the reciprocal of the number, that is 1 by 4. So this is the rate expression for the product. So if we have to write the rate expression for the whole reaction, then we have to equate all the thing. Okay, then what will be the rate? The rate will be minus 1 by 2 dA by dt equal to minus 1 by 3 dB by dt. You have to equate everything, rate of the R and rate of the P, equal to plus 1 by 4 dC by dt. That's it, student. It's so simple, right? So this is how you write the rate expression for the whole reaction. So now let's try the similar way for this reaction. N2 plus 3H2 gives 2NH3. Here the 3 and the 2 are the stoichiometric coefficient. This will be the reactant side and this will be the product side. For your understanding, we have done a rate expression separately in the previous problem, but from this we can directly substitute it, we can directly equate it. Okay, now let's write the rate expression for this reaction. Always remember, students, the rate expression, when you write the rate expression for the reactant side, it should be in a negative sign because the concentration of the reactant decreases while the concentration of the product increases. Okay, now let's write it. So first let's write the rate expression, then we will add the stoichiometric coefficient. Okay, negative of d n2 by dt equal to negative of d h2 by dt. Okay, now we see for n2 we don't have any stoichiometric coefficient, so there's nothing, right? So no need to include anything. But here we have 3 as the stoichiometric coefficient, so we have to put the reciprocal of 3, 1 by 3. Okay, now we have completed writing the rate expression for the reactant. Now we can write the product. We have to equate it. We have to equate everything. Okay. Now what it will be, the product side, it will be in the positive sign. So dNH3 by dt. Here the stoichiometric coefficient is 2, so we have to write the reciprocal of it. So that's it, students. This will be the rate expression for this reaction. Now let's see some other example. Okay, 5Br minus plus BrO3 minus plus 6H plus gives 3Br2 plus 3H2O. Here the 5, 6, 3 and another 3, these are the stoichiometric coefficient. Okay, now let's write this. Here this is the reactant side and this is the product side. Remember, reactant side, it should be in the negative sign. Now let's write the rate expression. What it will be? Negative of, here we have a stoichiometric coefficient 5, so we have to take the reciprocal, d of Br minus by dt equal to negative of, there is no stoichiometric ratio here, so we don't need to include anything. Negative of d BrO3 minus by dt is equal to negative of, here the stoichiometric ratio is 6, so we have to take the reciprocal, so 1 by 6 d of H plus by dt. That's it, students, for the rate expression for the reactant side. Now we will write for the product side. We have to equate it. Okay, for the product side, it will be positive sign. So we actually don't need to mention this positive, but for your understanding, I am just writing it. Okay. Positive, here we have 3, so 1 by 3. d of Br2 by dt. Again we are equating. I will write it down as I don't have any space there. Positive of, again we have 3 as the coefficient. 1 by 3 of, sorry, d of H2O by dt. That's it, students. This will be the rate expression for this reaction. It's so easy, right? Okay, now you are going to try this question. 2N2 plus O2 gives 2NO2. So try this question and comment the answer below. Here, for your understanding, I'll just say here are the 2 and this will be the stoichiometric coefficient. So what you have to do, whenever there is a stoichiometric coefficient, you have to take the reciprocal of it. And this will be the reactant side and this will be the product side. Okay, now comment the answer below. Thank you for watching.